Good afternoon, Anna, everyone. Yeah, right. Previously, we were in, I think, friction chapter. Yeah, good afternoon. And I gave one assignment also related to loss of motion and friction. For your sake, along with the key and solutions, I gave that assignment. I don't know how many saw that assignment and how many started, how many solved, how many completed. Okay, here, yeah, first question here, Ishan asked when, sir? Yeah, very good. Okay, Nana. How many saw the assignment what I gave, what I kept in your group, Nana? Hmm, really? Kirti, I did not send any assignment. Okay. Oh, I did not send. Yeah. Your problem is to check with your group. Once if you see here, when is Sunday? Saturday? December 5th. December 5th. Okay. December 5th. Hmm. Okay, then. Maybe it's my mistake. I thought that I kept it in your group. Then where I kept, I have to check. I kept in your group or some other group. Oh my goodness. Papam, what they do with this assignment. Poor fellows. Okay. Hmm. Yes, master. Yes, yes, Ishan. You are right. You are always right. Okay, then. Yes, yes, Manikanta Babu. You are right. Hmm. That we will discuss in work energy power, Nana Lakshmi Gayatri. Good afternoon. Right. Then here. Okay. It's not a big issue. I will send it, but it is a little bit tough. Try to solve it. I thought that I kept in your group, but unfortunately, this is human's life now. So I kept in some other group, right? Try it anyway. Okay, right, good. Then it is that time to change the chapter. Okay, so we are moving from loss of motion to another chapter called as collisions. Okay, right. Today I will try to put that in your group, Nana, but keep in mind, uh, comfortably I'm adjusting the parts here, whichever linked more, means like, suppose if you see here the spring models, they are more linked to work energy power. That's why I did not discuss the spring concept in this laws of motion. Okay, that doesn't mean I skipped. Actually, wantedly I just cut this part and I am pasting that one there in work power energy. Okay, wantedly. That's why don't think that I did not discuss the spring models. Okay, good, good, good. That is accordingly comfortability now we are seeing, so that we will discuss all the models related to springs there only. That's why even in that assignment, if you see any spring models, whatever, after keeping the assignment in your group, just skip them. We will discuss them in the next, when I start that work power energy chapter. Okay, na? Just round off, skip them. Then we will discuss them when I start the work power energy. Okay, and don't raise and don't put any comments on that in your group. Okay, all right. Why? Because your group is famous for comments. So no comments on that. Right, good. Then coming to here, collisions. In these collisions, we are coming to here. Suppose one body here moving. Suppose I take it as x-axis. Okay. One body here, which is there on the x-axis, moving towards right, means towards the positive x-axis, with a velocity, say some u1. Its mass is m1. Okay. And there is a second particle here. This is of mass m2. And its velocity is u2. Both are moving along the same line, like one-way traffic. Okay, moving along only one line. Suppose u1 in this case greater than u2, I take in the diagram. And here, suddenly he found failure of brakes for that vehicle. Right? Then what happens? The second body, sorry, the first body, since its velocity is more, okay, that's what I'm saying, right? Since its velocity is more and brakes are failed, immediately there is no other go, he collides the second body, collision. Okay. Here, who collides the other? M1 collides M2 or M2 collides M1? Why? Because this is not Rajnikant movie. Okay, suddenly turn back and colliding the other person. Okay, so yes, M1 collides M2. Yes, good. So in the figure, in the given figure, yes, M1 collides M2. Okay, good. And here, if you observe after the collision, okay, see here, what the damages occurred to the two vehicles, leave them. Just we are watching what happened after the collision according to our physics. Why? Because we are physics lovers. Okay, not animal lovers and non-living objects lovers. So here, after the collision, if you see, if M1 collides M2, immediately M1, M2 out of these two, first M2 tries to separate from M1. Okay. tries to separate from M1 means if you see here the two objects, sorry, first pink color, M1, and then blue color, M2. If you see here, these are the velocities after the collision. Okay, this is V1 and it is V2. Of course, this is mass M1, this is mass M2 after the collision. If you see here, practically what I'm saying, if you see V2 is greater than V1 after the collision, first body moves more with velocity than the first body. Okay, this one even in daily life also we see sometimes. Okay, without taking the care here, suppose if we forgot braking, applying the brakes, why? Because while riding, particularly in Hyderabad, we use the mobiles. Okay, that time only we get the calls while riding the bike. Okay, usually while talking with, chatting with others, shouting with on others, and here immediately we collide with the other person. After the collision, observe your velocity will be decreased. Whom you collided, his velocity will be increased. Am I right or wrong? After the collision. Yes, correct. Our velocity decreases. Whom we collided, his velocity increases. Okay, that's what I wrote here. So velocity after the collision, if you see second body velocity is greater than first body velocity. Before the collision, our velocity is more, other person velocity is less. Okay, that's why he says in this collision, okay, this is called as the first body approaches the second body before the collision. Okay, one point what I say here. And another point, the second body separates from the first body after the collision. Okay, are the two statements correct or wrong, Nana? Both the statements. Here where I put the arrow marks. Yeah, both are correct. First statement is correct. Second statement is also correct. Very good. And one more thing, if you observe, next point, in a collision, okay, the velocities of both the bodies change. Is this statement correct or wrong? U1 change it to V1, U2 change it to V2. Correct. Very good. This is also correct. Okay. Next question raises here, who changed the velocity? This is part of work power energy, Nano. You can see these collisions in work power energy. In the textbook, if you open the chapter work power energy, first you see the collisions, then work power energy starts in that chapter. Okay, that's why first I am starting the work collisions in work power energy. Right, good. Then coming to here, like a friction and loss of motion, same chapter. In the same way here, collisions and work power energy, same chapter. Okay, and next point here, sir, okay. Sir, U1 change it to V1, sir. U2 change it to V2. Sir, velocity by its own, it never changes, sir, unless you apply the force. So U1 is changed to V1 means some force is applied on first body. U2 is changed to V2 means again on the second body also some force is applied during the collision. Who is that force, sir? When they come to physical contact. Okay. So in the physical contact during the collision, not before, not after, during the collision. Okay. Due to the physical contact like this, they come in contact. Then first one has more velocity. So it tries to push the blue color dot forward. The pink color dot pushes the blue color dot forward. Pushes immediately at the tangent line of contact. There will be the normal reaction on the first pink color dot and the normal reaction on second blue color dot. Okay, which is called as normal reaction represented with N. Normal to the two surfaces, perpendicular to the surfaces in contact. Is it correct, Nana? Normal reaction we have to draw only on one or both in contact. In complete laws of motion friction, we use the same concept. We have to draw on both normal reaction. That's why the normal reaction acting on the first changes the velocity from U1 to V1. Now you can understand. Normal reaction on first is acting in opposite direction to U1. In opposite direction to U1 means U1 will be decreased. That's what I wrote here. U1 changed to V1. V1 is less than V2. So U1 is decreased. And the normal reaction on blue color dot, second body, in the same direction of velocity U2. Same direction, velocity will be increased. Velocity will be increased means V2 is more here. Now you understood who changed the velocities of both? Am I right, Nana? The normal reaction on first decreases the velocity. Normal reaction on second increases the velocity. Yes, 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 yes. So in physical contact, during the collision, the normal reaction is the cause to change the velocities of both the bodies. Very good. Now you say normal reaction is the internal force or external force? That in between the two bodies or from outside you are applying the force, normal reaction. Normal reaction. Ishan, think wisely. That is a contact force in between the two bodies, in between. So that is internal or external? Lakshmi Gayatri, think once. Yes, Ishan, this time correct. Normal reaction, friction, all these are internal forces, Nana. Okay, they lie in between the two bodies. That's why here the normal reaction is internal force. Okay, all of you accepting, Nana? Yes, okay. It is the internal force. Yes. Internal force of a system, not of a body, of a system. Yeah. In a system between the two bodies, in between the two bodies, the for normal reaction acts. So indeed is internal force of a system. Okay, and here observe from outside, next point. Here I write from outside. Are you finding out any force, Nana? Don't say U1 is the force. They are velocities moving with the constant velocities before the collision and after the collision. Are you finding out any external force from outside in the figure? Yes or no? Any external force? No. Okay, right. No external from outside. There is no external force. You may ask, sir, weight is acting now. Weight always acts vertically downwards. Sir, weight is an external force, sir. My weight is acting, sir. You may ask. But look at weight is perpendicular to their velocities. Perpendicular force won't change the velocity. Won't change the velocity means he is a waste fellow. He is not changing the velocity. That's why no need to consider the weight. Who is perpendicular to the direction of velocity. Now is it clear, Nana? That's why don't think about weight. Okay, shall I move to next point? Yes, good. Since there is no external force, now link to the laws of motion. Yes, link to the laws of motion. F external in that chapter is equals to Newton's second law, rate of change of linear momentum. Okay. All of you remember this formula, Nana? This is a basic formula in laws of motion. Okay. And here F external is 0. There is no external force. That implies 0 is equals to yes. Yes, thank you. D by dt of linear momentum. Okay. Differentiation of whom equals to 0 in differentiation. By differentiating whom, you will get 0. Anyone remember? Constant. Stress are good. Very good. Very good. So right. Good, good, good. That implies from the differentiation straight away I say here sir P is a constant. P of whom? P of system is constant. Why? Because there are two bodies in the system. Okay. P of system is equals to constant means that implies P of system, we say it as conserved. Constant means we use the word conserved. Okay. P is conserved means we say that implies it obeys law of conservation of linear momentum. Now you understood, Nana? The first fundamental concept means in a collision, any collision obeys whom? Yes, any collision obeys law of conservation of linear momentum. So irrespective of nature of collision, first of all, when we come to numericals, we have to apply law of conservation of linear momentum. Okay. Secondarily, we see what would be the second equation to solve the unknowns. But first of all, we have to apply LCLM, law of conservation of linear momentum. Okay. That law of conservation of linear momentum in the figure, if you see. Okay. Look at all the velocities are in the same one direction or not, along x-axis or not. Okay. That's why shall I call it as one-dimensional collision, Nana? Why? Because all are along x-axis, I cap, I cap, I cap, I cap. One direction only. So I'm giving the name here. Yes, yes, yes. The given figure is an example of one-dimensional collision. That is 1D, not 2D. Okay. So first we are going to one-dimensional collision here. Okay. Coming to here in the one-dimensional collision. Okay. So first I am going to here one-dimensional collision. Okay. Yes. According to LCLM, law of conservation of linear momentum, I write here what he said, P of system is constant means what is the total linear momentum before the collision? That should be equal to what is the total linear momentum after the collision. This is the fundamental formula according to LCLM. Okay. Related to this fundamental formula, we write here that basic equation. Okay. That implies I am writing here P before, even you also can say linear momentum means mass into velocity. Linear momentum m1 u1 for the first body, m2 u2 for the second body, since they are in the same direction, plus. So total linear momentum I write here before m1 u1 plus m2 u2. Any mistake here, Nana? Is there any mistake? What I wrote here? No, very good. No. So if I come to in the same way, what is the linear momentum after the collision? After, better he write here. This is after the collision. This is before the collision. Okay. After the collision, first particle m1 v1, second particle m2 v2. Total linear momentum. I write here m1 v1 for the first, since it is in the second direction, the second one also same direction, m2 v2 I write here. Okay. But keep in mind, it is applicable only in one dimension and traveling in the same direction. That's why better I write here vector form m1 u1 bar plus m2 u2 bar equals to m1 v1 bar plus m2 v2 bar. Okay, otherwise you may get some confusion. Okay, this is the one-dimensional collision. Okay, right. Yes, yes. Sir, why should I take the bars above the velocity, sir? That point actually I did not follow properly, sir. Very good. One dimension. Why I put bar here? That is your doubt now? Yes, sir. Then look at my example. Yes, yes, yes. I know, Ishan. I can read your heart. Okay, I know. It is there in your mind. Yes, example. Coming to here, Satvika. This is two bodies of equal masses. Okay, travel along the same line, but in opposite directions. With the velocities 2 meters per second and 1 meter per second, respectively. Okay. After the collision, the second body rebounds with the same velocity. Find the velocity of first body after the collision. Hmm. Is it correct, Amok? Think it's so? Not sure. Okay. Already I told. Amok said answer means it is Rajamouli mark. That's why from you, I never expect not sure. The answer not sure. Why? Because my belief is if you are confident, then only you put the answers. Now you say, is it correct, Mr. Rajamouli? Rajamouli Amok. Oh, okay. So your answer is right. Then we will check. Other one, try to toss your coins. What you got? Tossed your coins or not? Manibabu, tossing Isha. He did not come back. Oh, opposite direction, they won't collide. Ashwin Gayatri, along the same line, Nana. One-way traffic. Okay, in Hyderabad it is common. One is coming in the wrong way. Okay. If we see in Hyderabad no entry board, we wantedly enter into that way, na? Yes. Okay, Lakshmi Gayatri also got the same answer. What Amok got. Right. We will see. Oh, Srestha also got the same answer. Okay, then maybe these many people got the same answer means maybe correct. I don't know. I have to check it here. Two bodies before the collision, they are traveling in opposite direction along the same line. Here like this. Same line. They collide. Okay. This is before. Oh, Lakshmi Satvika got different answer. Okay. Right, we will check it, Nana. Who is correct? After the collision, who the second body rebounds. Yeah. Second body means this one. Rebounds like this. Rebounds back after the collision. That information we have. Mog, what is this? Again, two answers, Mr. Rajamouli. Rajamouli mark means hitta fatta. That's it. Okay. Right, good. Here both have same masses. M1 is equals to M. M2 is also equals to M. This is before. And it is after the collision. Ishan, yeah, you also said same answer what the others told. I will check it, Nana Ishan. After the second mass travel with, sorry, I did not write the velocities. U1 here in opposite direction with the velocity 2 and 1. 2 and U2, I write it as 1. Since they are in opposite direction, by assuming it as x-axis, better I write in vector form here. 2 I cap, this is opposite direction, to x-axis, that is minus I cap. Okay, I write by considering it as coordinate system. Positive x-axis, positive y-axis. Like this. Okay, a reference, x and y. Okay, after the collision rebounds, who m2, which is equals to m, rebounds, moving along positive x-axis with the same velocity, means v2 is equals to same velocity, magnitude 1, but in opposite direction, plus I cap. Any mistake here in my diagram, Nana? Exactly in vector form to avoid the confusion. Yeah, right. Now I apply the law of conservation of linear momentum in vector form. M1, that is M, U1 bar, I write it as 2 I cap, plus M2, M, U2, I write it as minus 1 I cap, okay, is equals to M2, sorry, M1 into V1, I don't know, I have to find out it, V1 bar, velocity of first body, plus M2, that is also M, into V2 bar is 1 I cap, and M1 is also M here. Okay. So I think you will get, yes, yes. Your answers, Amogu 0, right? Yes. Oh, so here M cancel, 2 minus 1. That is 1 I cap is equals to V1 bar plus 1 I cap here. Isha. Hey, last minute, don't turn back. Right. 1 I cap, that implies V1 bar equals to, I got here 1 minus 1, 0 I cap. Yes, 0 means it comes to rest. Who? The first body comes to rest. See here, if you don't apply the vector form, then there is a chance to do the mistake here. By seeing the values, usually what we substitute, m1, m2 same as happy, u1 2 plus u2 is 1 is equals to m1 v1 plus m2 v2, v2 is 1. Then here 1m cancel, then there is a chance to say the answer v2 is equals to 2 meters per second. Yeah, that's what I'm saying. If you don't use the vector method, okay, when their directions are not same, then there is a chance to get the wrong answer. Okay, that's what I clearly mentioned while applying the law of conservation of linear momentum. Don't use the vector form. Happy, don't use. You write like this. When both are traveling in the same direction before the collision, after the collision. Positive x-axis, positive x-axis, positive x-axis, positive x-axis. Before and after. Then don't apply. You can write the equation like this. Okay. But like this, positive x-axis, negative x-axis, not in the same direction, but along the same line. Then take care, step back, apply the vectorial method. Now, is it correct, Nana? Okay. Now understood the misconception here, where there is a chance to do the mistake. Yes, good. So when to apply without the vector form, when to apply with the vector form. Both I explained here. Okay. Same question if I write. In the above example, the two identical masses travel in the same direction, not in opposite directions. Same directions. And after the collision, the first body comes to rest. Find the velocity of second body. This one damn easy. You can say the answer. Yeah, I think this time you are correct, Mr. Amok. Yes, Lakshmika, this time is your answer is correct. Velocity of second body. Okay, I think all must get the answer name. Why others are taking more time here to say the answer? Yeah. This time movie hit. Last time Fattu. Mr. Amok. Yeah, this time correct, correct. Writing the question, Isha. Chai pilo. Okay. And then happily say the answer. Yes. Here, this time straight away, no need to use any vector form. All are moving in the same direction. Same direction means m1, u1. What he given on a velocity? 2 meters per second, 1 meter per second. Yes. m1, u1 plus m2, u2 is equals to m1. First body comes to rest. m1, v1 plus m2, v2 he is asking. No need to write any vector form. Why? Because both are in the same direction. In one sentence, sorry, in one line, Tuna. Ishan, what happened today? M cancel 2 plus 1 is equals to V2. V2 is equals to 3 meters per second. Ah, right, good. This is the answer. Now you understood the one-dimensional collision, Nana? Okay. If there is a physical contact between the two bodies, normal reaction changes the velocities. Yes. Now what I say, note here, in a collision, keep in mind the two bodies may or may not in contact. May or may not in contact. Physical contact, that's what I'm saying. Better I write in physical contact. Sir, without touching the other body, how you say that it is a collision, sir? Sir, without touching the other body, how it changes the velocity, sir? Really, is your statement correct, sir? Yes, my statement is correct. How, sir? Explain, sir. Sure, but I will explain in the next class. Okay, so you have to wait 24, 23 hours more. Okay, for the answer. Okay, Nana? Right. Bye, Nana, everyone. If you want the pages, you can take. This is the first page quickly. Not now. No, no, no. This is the second page. Thank you. Thank you. Thank you. and this is the third page. Okay, that's it. I will keep that assignment now only, Nana. Try to solve it, but keep in mind it is not easy. But if you don't get the answers, you can check there. I am sending the solutions also. Once you check the solution, and again you can try. Okay, along with the solutions, I am sending the assignment. Okay, bye everyone, Nana. Okay, now in few minutes you can check.